Now to a science mystery that has everyone talking. This, we're going to show you, is Charlotte the Stingray. She lives in North Carolina and she's getting ready to give birth, but here's the kicker. She has not had contact with a male for more than 8 years. It's like a Maury Povich episode of the animal kingdom, but scientists actually think in Charlotte's case, there is no father to her pups. And yes, stingray babies are called pups. But just one of the things you're going to learn here. Dr. Mercedes Burns joins us to shed some light on all of this. She's an assistant professor of biological sciences at the University of Maryland, Baltimore County. Doctor, good to have you with us. So experts say parthenogenesis, or virgin birth, is the only likely cause of Charlotte's pregnancy. Explain to us, what is that?
Sure. Yeah. Parthenogenesis is a form of reproduction, or asexual reproduction. So that means an egg being produced by a female is developing all on its own, has all the complements it needs, all the chromosomes it needs in order to develop into a zygote that can grow into a baby. So this is, and in this case,
go ahead.
Right. In this case, it's a pup that she's producing, or probably more likely 2 to 4 offspring.
I love that they're called pups, too. That is so cool. So this is actually more common than people think. In 2021, a shark in Singapore conceived without a mate. In 2006, several female Komodo dragons in the UK also gave birth without a mate. What is it that triggers parthenogenesis?
Well, so it's interesting because in many cases, we don't know what triggers spontaneous parthenogenesis. But in species that have regular asexual reproductive cycles, that trigger can be stress, overcrowding, or chemical changes in the environment that cause organisms to shift from sexual reproduction to asexual reproduction.
So this has been observed in every class of animals, I understand, except for mammals. Why do we think that is?
So there's a pretty clear-cut reason why mammals can't reproduce asexually, and it's called genomic imprinting. So what that means is essentially during our early stage development of zygotes or feti, if you will, there needs to be certain developmental genes that have to come from both sperm and egg. And so without those developmental genes functioning, the egg is going to arrest and it won't develop any further. So genomic imprinting is the reason why I kind of consider mammals all in on sexual reproduction. So they are physically incapable of reproducing asexually in the way that Charlotte appears to have done.
Let's talk a little more about Charlotte. When she does have her pups, what happens next? Do we know how caretakers will determine for sure how she conceived them?
Yeah, so after a couple of months, the pups will be born live. At that point, it's going to be important to examine those for signs of health, genetically and otherwise. And based on the sex of those offspring, whether they're male or female, and the developmental timing of those, we'll hopefully be able to determine what mode of parthenogenesis was used in order for Charlotte to produce those pups. And it's also interesting to consider that those pups, if they're female, may have a significantly higher chance of reproducing spontaneously through parthenogenesis themselves. So it's possible that this could be a heritable trait that we're seeing, and that could be passed on from Charlotte to any female offspring she has.
Very, very quickly, I'm going to play the role of Maury Povich here. Could it have been the shark?
No, it's highly unlikely. It could have been any of the sharks that Charlotte was in the tank with that fathered her pups, simply because Charlotte's a round ray. The sharks in the tank are so deeply diverged from rays that there's so many genetic differences between the two that it's just not possible. Hybridization could have been at play. Although I can understand a lot of folks being fascinated by the possibility of hybridization, it's pretty unlikely in this case.
All right, shark, you're not the father. Dr. Burns, thank you so much for joining us this morning. We really do appreciate your time.
Thanks for watching. Stay updated about breaking news and top stories on the NBC News app or follow us on social media.